Hello everyone, welcome to my channel. My name is AREF Malihi, and in a couple of courses I am going to, actually in several courses, I'm going to teach electrical engineering materials, starting with the most fundamental one, which is circuit analysis. I hope that I could be helpful, and my goal is to help as many students worldwide as possible. So if you like the contents that I provided and if you like the product, please don't forget to like this video at the end and subscribe to my channel so that I would be more motivated to provide more contents and to help you better. I plan to solve a lot of problems in circuit analysis and give you a visualization in this realm. So let's start with electric circuit. What is a circuit? So the very basic definition of a circuit is an interconnected components that allow an electrical current to flow. In this picture, you can obviously see a light bulb, a switch, and a battery could be used as a power source. I'm pretty much sure that we all have experienced some sort of an electric circuit in school or in college. And the most fundamental and the most easy ones are the ones that composed of a light bulb, a switch, and a battery. So this battery acts as a power source. This light bulb could be a consumer. You might in future call it a sort of resistor. And this switch is to control the flow of current in our circuit. We will know more as we progress through this course. And now let's get to another important terminology in electric circuit, an electric charge, which is shown with small q or capital Q. An electric charge is nothing but the amount of electrons or energy that passes from one body to another. That could be caused by different modes of conduction, induction, or other specific methods. We have positive and negative charge. So it's a physical property of a substance, of a material, that causes it to experience a force when placed in an electromagnetic field. We will know more about electromagnetic field in future. Electric charges can be positive, we know them as protons, or negative, that we know them as electrons. Like charges repel each other. If we have two positive charges, they just repel each other. And on the other hand, unlike charges attract each other. If we have one positive and one negative charges, they attract each other if placed in the vicinity of each other. An electric charge is a conserved property. And we know this concept in physics, meaning that it contains a quantity such as energy at a constant overall total. It has to be in an isolated system. For example, the momentum of a system is conserved unless an external force is imposed on it. So when we say conserved, we consider an isolated system when there is no external force. And let's move on to the unit of charge, which is coulomb. We show it with C, with capital C in equations. And there are negative charges, as I said. We know them as electrons. Positive charges, we know them as protons, and zero charges, which are known as neutrons, inside an atom. And one electron equals 1.602 times 10 to the power of negative 19 coulomb. Let's move on to materials categories from electrical perspective. So from electrical perspective, the materials are categorized into three main categories, starting from the most important one, which are conductors. Conductors allow the electricity, allow the electrons to pass. A material that allows the flow of electricity through means, metals like gold, copper, aluminum, or you might call it aluminium, silver, and you know better. So many metals in the market are all among conductors. They conduct, they allow the electric current to pass. And the opposite of conductors in electricity are non-conductors, that we know them as insulators. An insulator is a material which does not easily allow electricity to pass. Why we say does not easily allow? I could have said does not allow at all, but each insulator has a voltage break or a break voltage. Okay, so the insulators, based off the intensity of that insulator, has a breakage voltage. We're gonna learn that meaning in this course. Just stay with me and I will just walk you through all those concepts. If I were to mention some insulators, I would say plastic, wood, rubber, glass. They're all examples of good insulators. And my favorite one is semiconductors or semiconductors. Semiconductors are neither conductors nor insulators. They're partially conductors. You might think, why do we need partially conductors? We either want the electricity to completely pass or we don't want it to pass. What are semiconductors? You will be much more surprised once you get more familiar with semiconductors in diodes, in integrated circuits known as ICs, in transistors, even in motors. They are used as brushes. The materials used in motor brushes are semiconductors. You will learn more about them. And now let's get familiar with some basic electricity terms in a circuit, starting with current. Electric current is the rate of charge passing through a point in a complete circuit. So in this circuit, you can see these red arrows. They are representative as electric currents. Electric currents are the rate of change of charge with respect to time. So if I want to show them mathematically, I would say I, which is current, equals the derivation of charge with respect to time. So the rate of change of charge with respect to time at any specific point of a circuit is called current. The unit of electric current is ampere, and it's shown as A, capital A. And the direction of current, that one is one of the challenging concepts in electrical engineering. So we have a conventional direction, which is the movement of positive charge. However, in reality, we know that only electrons move and protons, they don't move. Positive charge don't move in reality, but conventionally, we consider the direction of current as the direction of positive charge. I repeat, it's just conventional, and in reality, this is not true. There are some other basic electric terms, but I'm just going through the most important ones. The next one is electric voltage. Voltage, which is also known as potential difference, is the pressure from an electrical circuit's power source that pushes charged electrons through a conducting loop. And we both know that conducting loop is circuit, right? So the pushes that a power source does for electric charges or electric currents to go through the circuit, that push, that pressure is known as voltage. Voltage is the driving force that causes current to pass through a circuit. I can just put it in other words this way. And there are two major types of electricity flow. You might already know them. We have AC and DC. So what is AC, or alternative current? If the direction of electricity, either current or voltage, changes periodically or reverses periodically, and the voltage changes from positive to negative and vice versa, this is called an AC signal or AC voltage or AC current. Doesn't matter, current or voltage. AC or DC concept is the same. So if the direction of electric current or electric voltage periodically reverses, when I say periodically, it has to be a period that just repeats itself. And AC is the type of electricity that's delivered to homes and businesses through power lines. So the real power that we're receiving at home is AC power. We get to that point. And the waveform of AC is usually a sine wave. So you're definitely familiar with a sine wave, which is this wave you see in the picture. Another type of electricity flow is DC, also known as direct current. So if the value of voltage or current is constant over time, this is called DC or direct current. Doesn't matter voltage or current. The electric current flows in one constant direction, and the voltage is always constant. DC is the type of electricity that usually comes from batteries, solar cells, or AC-DC converters and used for electronic devices. We might get to that point more, but this was the end of the very first course, and I'm really happy that I shared my information. If you liked it so far, please give me a thumb up and give me the energy and motivation to continue these courses. I have a lot more to come. Thank you very much and have a perfect day.